Okay, so this is the 2-4 notes. This is looking at population variance and standard deviation measures of variance. For those of you using a TI Inspire, we're still using menu 411 like we did with the mean process. For those of you that are using Desmos, I'm going to show you that here in a minute on Desmos. So the population variance is the mean of the squares of the deviations, which is kind of scary to hear about, but it's not really all that big of a deal. This just tells us the process that we're going to be using to find that. Variance doesn't have a whole lot of use in math or in statistics, except to help us find the standard deviation. And standard deviation is one of the most important things in statistics. It allows us to compare other data to each other, different types of data to each other, and give a real good indication of changes that are going on. On your calculator for the TI Inspire, sigma, which is what this little funny looking O with a tail is called. Sigma squared is going to be under, is not going to show up on your calculator. Sigma with a sub x will be what you'll see on your calculator. To get sigma squared, you actually have to take this answer that your calculator gives you and physically square it in the a different calculator mode. Okay, so that's something that we're going to be working with. For those of you in advanced AP statistics, you will need to know these formulas, and I believe they're on the formula chart. Okay, so we're going to work through both on our calculator and on Desmos with these to make sure that everybody knows what to do. So on the calculator, we're going to take our data point entries. That's what we're doing. And again, it's new menu 4, put in your X, and then just type in your data. And I kept the data points short, so it'd be easy to type them in fast. Okay, then you push menu 411 and say okay. Pick X, because that's what you called it. And then you'll look. What you're looking for is going to be two different things. Now, if you're talking about a sample, you'll be looking for the XSX. If that's a sample, that's what you're looking for. If you're looking at a population, you're looking for the O or sigma X. So in this case, we were talking about a population. They even said population in the question. So that tells us we're looking for the OX. Now that is sigma x, but that is not variance. That is the standard deviation. So what you have to do is push Control Dock and pick a calculator. And a little trick you can use is the var button, which is right above the 9, will let you pick all of the information that was already in the calculator from the previous activity. And as you can see, sigma is right here on this list. You can use the same activity if we're trying to use the X bar or the max and the min. So there's lots of great things that we can use this little bar button for. So we take and say, I need my standard deviation, and then you push the square button to square it, and that will give you your variance. You should always write your variance unless it's told otherwise. Variance and standard deviation should always be written at least 3 decimal places, unless it cannot be written that way because there wasn't 3 decimal places to go off of. Now, if we're doing it by hand, we first have to find our mean, which is add them all up and divide by 4. Then we take the difference between the x minus the mean. That's what this inside the parentheses means. We do that for each one of our data points. Then we square each one of those answers, and then we add them all up. That's the top. Then we divide that answer by how many data points we had, and that tells us our variance. Then we take the square root of that, and that tells us our standard deviation. So if you're using the calculator to find this, that is perfectly fine. If you're using, you want to do it by hand, like I learned it, that's perfectly fine as well. So it just depends on which way you're doing it. Just be very careful not to do any rounding until your last step, especially in this step right here. Don't round here until you've rounded that, until you've done this step. Because if you do, you'll end up with an error from rounding errors. Okay, so if you are in Desmos, switching to Desmos real quick, we would do the same thing. We do our table, we put in our data. And then you can see how it found the mean for us. It found the median, which we didn't need this time. For standard deviation, the best way to do it is to use the function key, which is over here. And you go to stats. And there are two standard deviations on here. Standard deviation P is for population. Standard deviation without the P is for the sample. Also, you see here median, max, mean, median, max, min, quartiles, which we'll use later. So those all are in here. So standard deviation population, and then we just put in X1, and it finds our 4.319, which I rounded to 4.31 or 4.32. Okay. So again, to get to that, I'm closing this out. To get to all of these little tricks, you click on the button that next to the keyboard, then click on the function key and pick stats off of this menu. And that will get you to the list of different things that you can use for statistics. Okay, let's go back to here. Okay. So finding the standard sample standard deviation and variance is basically the same formula. The difference is you use X bar instead of mu, and it's n minus 1 because you're allowing for an allowance because you have a smaller population. So this actually should say sample. And then the square root of that will give you that. So doing it by hand, you put in your data, find your mean, same way. Notice the mean didn't change. It's still 32 on this for our example because our data points were same. We still do x minus mean, and then we still square it. Then we add them all up. So at this point, we've done all the same work. Where it changes is where we do the sum divided by n minus 1, which is 3. And then that gives us a square root. Now, here's something to remember. Your S will always be smaller than your mean. That makes sense because your sample, your standard deviation on your sample will always be smaller than your population standard deviation. Why? Because your sample will always be bigger than your population. Why? Because it's overestimating, because it's making an estimate about the population. Okay, so we're overestimating just a bit. So that's what it is. Now, in your calculator on the TI Inspires, again, you will only see the SX for sample standard deviation. To get this, you have to use the var key, square it. So again, population, sigma squared, sigma, sample, S squared, okay? Okay, so now that we're looking at data, we're going to be looking at that bell-shaped curve. And there's a couple of rules that help us to keep this curve in the perfect order and also to recognize where things are going on. 68% of all data should land in the middle of the bell, like in that big part of the bell, okay? So if you want to think about it, this is basically like over here is your A students, here's your B students, here's your C students, here's your D students, here's your F students. If you're talking about grades to help you to figure it out. I've always used this because it makes most sense to me. Okay, so people that make A's especially in college level, only about 2% of students that take most college courses make an A. 13.6% will make a B. 34.1% of that class will make a C. About the same will make a D, and about 13% or actually more like 15% because you add them all together, will get the F or fail the class. Okay, so starting from the inside, you have 68%. And then this area from here to here is 95%. And from outside to outside is 98%. Okay, so that's how that works out. So when we're looking at it, you can actually use that to find information about where things are. Now, if you look at the bottom here, you'll notice that I have the sigma symbols, positive and negative. And the middle is 0. That is where your mean is. So your mean line is always going to be the center. Okay, so basically what this is saying is one standard deviation away from the mean, so one step away, is going to be on either side is 68%. Okay, 2 standard deviations away from that around that center will be 95% of the data, and 3 standard deviations will be 98%. Anything that's outside the two standard deviations is considered outliers. So remember I talked about outliers being things that didn't seem to belong? That's going to be the people that are on the outside of that 2 standard deviations. So when we're solving a problem using empirical rules, the mean value of the land of an acre of the sample is 1,500. That's your middle. Always start with your middle. And the standard deviation is 200. So that means plus 200 minus 200 on either side, giving us 1,300 to 1,700. So what they're wanting to know is what percentage is between 13 and 1,700. Well, that's that first step. That's this first direction right here, which was, again, the 68%. So that's what 1,300 to 1,700 is when within one standard deviation. So it's 68% of the farms. Okay, so we can also look at this. I'm actually going to skip over this because I don't even think this is in most of what you guys have to deal with. But this allows us to actually figure it out. Chavez's, actually, I won't skip it. Okay, Chavez's theorem allows us to figure out what standard deviation it is percentage-wise, okay? So if you have k is 2, 2 being the standard number of standard deviations, 1 minus 1 divided by 2 squared will be 75%, so it lies within 2 standard deviations. If it's 3, then it's within 3 standard deviations. So it's kind of gives us an idea of how to do it. So we have mean is 57.2. We have k is 2, so 2 standard deviations times the standard deviation amount will give us a quick amount of the 75% is between what and what, okay? Okay. Standard deviation of a group data. This one is getting a lot more complicated and it's more for the upper level students, but it works back to the same information we were doing before. You have your X values, you have how frequently they come up. 0 came up 3 times, 1 comes up 15, 2 comes up 24 times, and 3 comes up 8 times. Instead of putting all of those zeros, ones, twos, and threes into your calculator, 50 different numbers, you can group them and then do X times F. So there's 3 zeros, which would have added up to 0. There's 15 ones, which would have added up to 15. There's 24 twos, which would have added up to 48. And then there's 3 eights, which would have added up to 24. That's what this really meant, is what would that part of the groups have added up to? And then we add all that up to get our grand total, or sum. Then we do our mean, which is the sum of the totals divided by how many there were to get our mean. And then we keep going from there. We go back to our x. X is 0 minus the mean, and then square it, and then multiply it times the frequency because it's 3 times as many times that happened. 15 times it happened here, 24 times it happened here, 8 times it happened here. Then we add it all up. Then we divide it by n minus 1, and you get your variance and your standard deviation. For only really advanced kids will you have to do this kind of work. But if you set up your table, you take your function, your equation, and you break it up into its components, it makes it a lot easier to do this kind of thing. Okay. Sometimes we have to use the midpoints because we start with our classes. So we find our midpoint, multiply times the frequency, find our mean, subtract from x, square it, multiply times f again, and then divide by the n minus 1. In class, for those advanced kids, we will go through this. For everybody that's doing regular classes, I don't believe you'll have any problems like this. I don't believe I assigned anything that you would have to do these. Okay, that's all of 2-5 or 2-4.